And I'm gonna share. All right, so let's take a look at the PDF, which is our guide. All right, so these are just very simple commands. We're not going to do this whole thing. We just need to know how to do the calculate the hash values. Okay, so that's basically all we're going to try to do here. Okay, so you can see open SSL. We pick what hash value we want, maybe a key, and that's it. Okay, so that's basically all you have to do here. Okay. So let's go ahead and go back to our terminal. I'm going to hit clear. ls-l pwd. All right, so I'm going to exit out of this one, and I'm going to create a new folder. And I'm going to call this one integrity and hashes. Hash values. Now I'm going to cd into this folder. Okay, so there's nothing in here. So we're going to create once again, same thing. We create a file. So I'm going to create file nano plain.txt. And you can say your name. So, John Smith something. Okay. This is a secret file. Okay, this is a secret file that will be encrypted. Hashed. And sent to my classmate. Okay, something like that. Right, so we have one. All we want to do is hash these. Now this could be this is a short file, but this could be much bigger. So, if you're curious, go ahead and copy, go to Wikipedia or something, copy a whole bunch of paragraphs in here. And that's a good exercise, actually, because whether it's a very small file or a really large file, it generates hashes, okay, of similar size. So I'm going to do Control X, Y, enter. So ls-l. Got my file there. It's got about 93 bytes. So now we're going to try to create some hashes for this. So open SSL. Digest, DGST should give us that. -MD5, right? So that's one of the hashing algorithms. And then just a plain file. So this is pretty straightforward. And that's it. You see that? This is the hash value. Got it? So when you're going to send this to your partner, right? The problem says that you should achieve confidentiality and integrity in one shot. And don't worry about the key. So what are the things that you send here to your partner? What do you send them? You know what I'm asking? So if you're just achieving integrity, how about that? I asked you on the exam, given this scenario, just achieve integrity. What do you send via email? Well, we didn't use a key. Oh, do you mean that? That's the hash, not a key. Yeah, that's the hash. So what do you send? We didn't use a key, right? We just used the MD5 algorithm, although we could use a key, but we didn't. So what do we send? Just the hash. Just the hash? For integrity? Mm-hmm. What's the point of integrity? Think about that. What's the point of integrity? Hmm?
Make sure nothing is being changed.
Make sure the file hasn't been changed, right? So you're sending the file, and what else should you send? The file and the hash. So when they receive the file and the hash, what are they going to do? Verify it, exactly. Which is basically just run this again, right? They can just run OpenSSL digest MD5 plain, and it's going to give them what? This, correct? And they have it because you sent it. So what do? They match them. You guys understand? And then you verify. That's it. So later on, we'll explore algorithms where we have sign and verify, that kind of thing, and then it'll return true or false. But here you're just like at a very basic level doing this. So what you need to send your friend is the plain text and the hash value. If you just send the plain text and the hash value, the plain text is not encrypted, correct? So anyone can see it. So you're only achieving integrity. But what if I ask you to send that file to your friend and achieve both confidentiality and integrity at once? Then what do you need to do? Yeah. You encrypt the file, right? And send the encrypted file. When would you calculate the hash? Sure. Why not, right? Yeah. It doesn't matter. You can do it after it's, that's the beauty of it. So it's like, you know, you can take the plain, encrypt it, get the binary, hash the binary, and then you just send what? What do you send? Via email. Yeah, exactly, right? And then they have the key, assuming somehow it's been securely exchanged. So then what do they do when they get the binary and the hash? Sure, and that gives them the plain, and also they can check the hash, right, while it's encrypted, and that way you can check both integrity and confidentiality. Got it? Do you guys see that? Does that make sense? Any questions? Yeah, this is what we're doing, right? So we're like, remember what I said, we create one primitive and then another one. And so we start with a plain text file, maybe we encrypt it, then we hash it, and then we just need to be careful that we know what we're sending, and we should be good. Any questions? All right, so let's do another one. This time we're gonna do SHA-1. Okay. So we just have to change this to SHA-1 instead of MD5. SHA-1. So what do you expect will happen here? What do you think will happen? What is SHA-1? It's supposed to be better. So what do you, Longer. Yeah, very good. Is it longer? Yep. It is, right? That's kind of how it works. So, and then we can try one more, which is SHA-256, which is supposed to be even better. See that? And it's even longer. So the longer implies that it's maybe harder to break, etc. And so that's kind of what we're doing. Okay, so this kind of illustrates this example. We're also going to try later, like next week, some examples where we provide a key. You know, we can use that, and that just provides more security because people also have to have the key to calculate the hash. Okay, guys? All right, so that's for now, this is the demo. So just very simple. I'm going to put this under integrity and hashing with OpenSSL. And then I'll give you guys the rest of the time that we have just to work on the lab and ask any questions. And then next Tuesday, we will go back to the lecture, right? And pick up where we left off. So let me stop.